Everyone, hope you're having a wonderful day. So last time we were talking about phase changes and how in a phase change the temperature, even if you're heating a substance or cooling a substance, the temperature does not change because that heat or removal of heat is going into changing the position of the particles. We also had talked about that solids, because the particles are closest to each other, they have low potential energy, followed by liquids, and then gases have a pretty high potential energy. You'll also notice that the liquids and the solids are closer in energy to each other compared to the gases. That's because the position of the particles in solids and liquids are relatively close to each other, similar to each other. Compared to gases, the position of the particles is really different. Particles are very far apart in a gas. So you'll see that the phase changes that we see in red, these are all endothermic processes. Endo means in. We're talking about the heat is going in. Endothermic, thermic means heat, and it's going into our system from the surroundings. So if I have some ice and I need to turn it into liquid water, I have to put in energy into the ice, so that ice has to absorb energy in order to melt. Or if I have liquid water and I'm trying to vaporize it, I have to heat it up, give it energy in order to become a gas. Same thing with a solid. If I have to sublimate it, turn it into a gas, I have to add in energy. So all the ones that are in red are considered endothermic processes. Your energy is going into the system to get it to go from a low energy state to a higher energy state, from a solid to a liquid, or from a liquid to a gas, or from a solid to a gas. You're going up in potential energy. So you have to add that extra energy. Versus condensation, freezing, and deposition are exothermic process. Exo means exit or out. Thermic means heat. So the heat or the energy is going out of your system. So if I have a gas and I want to condense it into a liquid, gases have higher potential energy than liquid, so I have to release, give off that extra energy to go from a gas to a liquid to get it to condense. Same thing with freezing. If I'm at a liquid and I'm trying to get to a solid, that is an exothermic process. That extra energy has to be released or taken out of your system in order to freeze, and similar thing with deposition. So in all these phase changes, you are changing the potential energy, so you either have to absorb more energy to raise your potential energy of your substance, or you have to release that potential energy to lower the potential energy of your substance. So freezing, going from liquid to solid, that would be exothermic. Your liquid releases energy and turns into a solid. Melting would be the opposite, is endothermic, because your solid has to absorb energy in order to turn into a liquid. Condensation would be exothermic. Your gas has to release energy and turn into a liquid. Vaporization is the opposite. It's endothermic because your liquid has to absorb energy in order to turn into a gas. Deposition is exothermic because your gas releases energy as it turns into a solid. And then sublimation is the opposite, is endothermic, because your solid has to absorb energy in order to turn into a gas. So you need to be able to remember the names of these phase changes and know whether they're exothermic or endothermic. Boiling point is the temperature at which a substance boils, which means turns from liquid to a gas. And basically your liquid and your gas phases are at equilibrium. So at that temperature, any particle that's going from liquid to gas, you have another particle that can go from gas to liquid. And so boiling point of water, for example, is 100 Celsius. Condensation point is the same thing as the boiling point. It's the temperature at which your gas will condense into liquid, or it is the temperature at which your gas and liquid are at equilibrium. So the condensation point of water is also 100 Celsius. So boiling point and condensation point means the same thing. It's the temperature when your liquid and gas are equal or at equilibrium. Same thing with freezing point and melting point. Those are the same thing. They're the temperature at which your liquid and your solid phases exist in equilibrium. So the freezing point of water is 0 Celsius. The melting point of water is also 0 Celsius. let's talk a little bit more about evaporation. So evaporation is when you take your liquid and turn it into the gaseous phase. And, let's say I have a cup of water. Let's say I put some water in my mug here and I let it sit. And I come back like next week. You notice that the water level went down. But what's the boiling point of water? The boiling point of water is 100 Celsius. In this room, it's probably like 22 Celsius, 25 Celsius maybe. It's nowhere near the boiling point of water. And yet, the water evaporates. Well, why does that happen? Well, here's the thing. In your liquid, when we measure the temperature, we say that that's related to the kinetic energy, which is related to the speed and all that stuff. But in reality, not all the liquid particles are moving at the same speed. Some of these liquid particles are moving very, very fast. Some are moving super slow. Some are moving kind of in between. And so the ones that are moving very, very fast, if they are close to the surface, because they're moving fast, they're going to pop out of the liquid and turn into a gas. Think of popcorn. When you are popping popcorn, if you've ever seen it, what happens is some of these kernels are like moving super fast. They're popping. As they pop, they move pretty fast. And some of them are just, very, very slow. Some are kind of in the middle. The ones that are moving fast, as soon as they pop, they move very fast. If they are close to the surface and you don't have a lid on, they're going to escape. So it's the same idea here. The particles in the liquid that are moving very fast, if they're close to the surface, they're going to escape and turn into a gas. And so those gas particles will escape, and you're going to have less liquid because some of it has turned into a gas. And so that's why if you leave a water bottle or a cup of water and come back like after a couple of days or a week, you'll see that the water level went down, even though we're nowhere near the boiling point, because some of these particles are escaping all the time. Now, evaporation is a cooling process. What that means is it's endothermic. So in order for those particles to escape, they either need to absorb heat. That's what happens when you boil. You heat it up to give it energy so that it can escape. Or if you're not heating it, like if you're letting it just sit, what happens is the fastest moving particles, the particles with enough kinetic energy, will escape and become a gas. And so what you're left with here are the colder particles, the ones that are moving slower, which means colder particles. And so as these particles escape, the liquid actually becomes colder and colder if you don't provide it any heat. So it is a cooling process. The stronger the intermolecular forces you have, the slower the rate of vaporization. So if you have a substance that has very strong intermolecular forces, those particles are going to be really attracted to each other, and it's going to be harder for them to vaporize and turn into a gas, harder for them to escape and turn into a gas. So you'd have it evaporating much, much slower. Things with weak intermolecular forces, where the particles are not very attracted to each other, those are pretty easy to vaporize. So, perfume or acetone, those vaporize very quickly. That tells us that they have weak intermolecular forces, compared to water has stronger intermolecular forces because it evaporates slower. Evaporation is an endothermic process, like we said, which means that it absorbs heat and is cool to the touch. And that's how sweat helps you cool down. So the sweat basically is a liquid. When your body produces sweat, that's a liquid. That in itself does not help you cool down. It does not lower your temperature. What helps you cool down is because the liquid, when you sweat, is at the surface of your skin. In order for it to evaporate, it has to absorb energy to go from liquid to gas, because gases have higher potential energy, right? So for those liquid particles to evaporate, they have to absorb heat from somewhere, and so they absorb heat from your body, and that's what cools you down. Also, the very fast-moving particles are the ones that escape first and start evaporating first. So the liquid that you have left on your body is actually colder, and that also cools you down. It's the same idea if it's a hot summer day and you go swimming. And so you take a dip into the pool, come out, you're all wet, and you feel cold. Even though it's pretty warm outside, you still feel cold. That's because you have water particles on your surface, on the surface of your skin. And so those water particles start evaporating. And as they're evaporating, they're drawing heat from your body. And that's causing you to cool down or feel cold. So evaporation is a cooling process. We do have a Teach an Adult in our packet. So what I would like you to do for the Teach an Adult is take 2 cotton balls, if you have them. If not, you can use 2 Q-tips. If not, you can just dip your finger into the liquids. But one of them you want to dip in water. The other one you want to dip either in acetone, nail polish remover, or you can use rubbing alcohol, either one, whichever one you have at home. And I want you to put a tiny bit of the liquid, both liquids, on the surface of an adult's hand. So on one of their hands, they should have a little bit of water. And on the other hand, they should have either acetone or alcohol. And have them feel it. They should both feel pretty cold because they're both evaporating and drawing heat from their body, right? But one should feel colder than the other. And the one that feels colder than the other is the one that has weaker intermolecular forces because it evaporates much faster. And so it draws the heat from your skin much faster. And so you feel it colder, even though they're both cooling your body. But the one with weaker intermolecular forces is going to escape faster, turn into gas faster, and it's going to draw heat from your body faster and cool you down faster. The water will still feel cold, but because it has stronger intermolecular forces, it's not going to feel as cold as the other one. So you should try it and then try it with the adult and have them answer the questions. Condensation is the opposite of evaporation. So that's when you change from gas to liquid. And so you achieve a dynamic equilibrium with vaporization in a closed system. What does that mean? So let's look at this diagram here. So let's say I have this mug and I fill it up with water. I come back in a week and the water has gone down, right? Because the water is evaporating and it's going into the air, into the room, right? Well, what if I close this mug somehow? I put a lid on it somehow and I come back in a week. Or you have a water bottle and you close it and it's really tight and you come back in a week. What happens to the water level? Nothing. Even though the fast escaping particles are escaping and turning into a gas. But why is the water level not changing? Well, here's what's happening. So initially, some of the water particles escape and turn into a gas. But then when you have enough water vapor gas, in here, well, those particles, some of them are moving fast, some are moving slow. The ones that are moving slow can slow down enough and start to condense and turn back into a liquid. If you leave it long enough, you achieve dynamic equilibrium. What does that mean? That means that the rate of evaporation is equal to the rate of condensation. So for every water molecules that turns from liquid to gas, you have one that's turning from gas to liquid. That's what dynamic equilibrium means. What's equal is the rates of condensation and the rates of evaporation are equal. Dynamic means changing. That means the particles are always changing. The liquid is turning into gas. The gas is turning into a liquid. The particles are changing all the time, but to us, they look like nothing's changing because their rates are equal. So we see the same water level the whole entire time. Just like evaporation was a cooling process, condensation is a heating process. So when something condenses, turns from gas to liquid, it will release heat to the surroundings in order to do that. All right, that's it for today's lesson. Hope you have a wonderful day.